Friends and friends, welcome to my YouTube channels. Today I am going to derive one equation, slope and deflections of a cantilever beam with a point load at the free end. So what is the trick here? What is the concept here? So deflections in cantilever beam will be maximum at the free end only, and slope also will be maximum free end only. Cantilever one in fixed, other is free. So load acting in the free end only. So what is boundary conditions we taken here? X equal to L, because x equal to 0 we taken here, so x equal to L here. So x equal to L, now slope and deflections both will be 0. But here if x equal to 0, because we are taking from left side to from right side to left side, so point load W here free end. Here x equal to 0, that is maximum deflections will come also, and angle will be maximum, that is called slope also will be maximum. So what I wrote here, considering the section XX at a distance of x from the free end, we taken free end. So we taken this moment here XX, W into X. Why negative? You see the sign conventions what we obeyed here. This is the section, right side, left side. Right side clockwise will be negative. If taking section XX, W into X, this rotation is clockwise negative, so minus WX. So this is the taken at the section XX moment. Now we'll derive from the, we'll take the bending moment equation. So we know that from bending moment equation, we know the bending moment equations is EI d square y by dx square. This is called bending moment equation. This is called bending moment equation. Now we'll substitute these bending moment equations here. So what is the here? EI d square y by dx is square equal to, what is bending momentum? Minus wx. Now we'll integrate this. Integrating both sides. What will be the integration? EI will take out Young modulus and moment of inertia. E is Young modulus, I is moment of inertia. D square y by dx is square equal to minus w x dx. So now we'll integrate this. So already know dy by dx integrations will be EI. The integration will be dy by dx, not EI. This is the integration. Now this integrations x na x square by 2. Then some constant C1, because this is indefinite integration. So section C1. So remove, we have to find the C1. So we have to apply the boundary condition. So how we'll get the C1? So dy by dx equal to 0 when x equal to L. We'll substitute dy by dx equal to 0 when x equal to L. So what is equations will become? EI 0 equal to minus W by 2 L square, W by 2 L square plus C1. So C1 you will get WL square by 2. C1 what we will get? WL square by 2. So we are getting here C1 WL square by 2. Now substitute this C1 in these equations. Take this equations 1. So we apply the boundary conditions, then substitute C1 in equation 1. So what is equations 1? EI dy by dx, this is the deflection, dy by dx nothing but slope, dy by dx is nothing but slope, equal to minus w by 2 x square plus WL square by 2. This is the slope equation. This is equations is known as, you can write, this is called slope equation. This is known as slope equation. Now slope will be maximum. When slope will be maximum? When x equal to 0. When slope will be maximum? When x equal to 0. Because you are considering length from free end. So when slope will be maximum, x equal to 0. If x equal to 0, slope will be maximum. You can write if x equal to 0, if x equal to 0, slope will be maximum. Now substitute these equations, slope equations. So give equations 2. From equations 2, EI slope will be maximum when x will be 0. So this is 0 plus WL square by 2. So what we will get finally? dy by dx maximum, or also which point? Theta b. Theta also equation of the symbol of this slope only. So theta b maximum when WL square by 2 EI. This we got the equations of the slope. Equations of the slope we got. Black color, blue color. So this is the equations of the slope we got now. We got the equations of the slope. Maximum slope you can write. This got the equations of the maximum slope. WL square by 2EI. Okay, now we'll integrate again. We'll integrate again equations where substituted C2. So here in slope equation, again integrate equations 2. So what we'll get? EI, this will get y. So slope becomes deflections. Y is deflections. Minus, again we'll integrate. No, so write one steps then. dy by dx equal to minus w by 2 x square dx plus wl square by 2 dx. Now we'll integrate. EI, Young modulus moment of inertia, into y is equal to minus w by 2 x cube by 3 plus wl square by 2 into x plus some constant c2 come now. Because in different integrals some constant will come c2. So this is the equations came. What is EIY minus w x cube by 3, okay, w by 2, then plus wl square by 2 x c2. Now when will be the y? Y, that means deflections will be 0 when x equal to L. When x equal to L, deflections and slope will be 0. So we will substitute if x equal to L, then what will be the y? Y is nothing but what is deflection. Then deflections or y becomes y maximum. When x equal to L, y becomes maximum. So you will get the C2 value. Substitute in this equation, okay. So now here I will write again. Here we will write again. So now substitute in this equations. How much given? 2. Give equations number 3. From equations 3, EI y becomes y maximum. First we need C2 now. So x equal to L. X equal to L. First you have to put y equal to 0 here because we need C2 value now. So put y equal to 0. Put y equal to 0. That means deflections will be 0 where? When x equal to L. Deflections will be 0, x equal to L. Substitute in this equation. So what will come? 0. Put, because C2 value I not taken now. So C2 value first we have to take minus w by 2 or 6 you write here. 2 3 are 6, x cube na L cube plus WL square by 2 into L plus C2. So we'll get the C2 value here. So what will WL square by 6, WL square by 2 into L, then C2. C2 will come WL cube. So C2 we are getting minus WL cube by 3. We are getting C2 value is minus WL cube by 3. Now we'll C2 value, substitute C2 in equations 3. So what equation 3 will become? EIY equal to minus W by 6x cube plus WL square by 2x minus WL cube by 3. This is got deflection equation. This you can say, this equation is known as, give equations number 4. This is called deflection equation. Deflection equation. This is known as deflection equations. EYW by 6x cube plus WL square by 2x minus W. Now, when deflections will be maximum? Deflections will be maximum when x equal to 0. Deflections will be y becomes y max. Y becomes y max when x equal to 0. Substitute in this equations number 4. Substitute in equations 4. What will get here? EI y becomes y maximum. Then what will be here? X equal to 0. So what will come directly? WL cube by 3. Now finally what will come? So we'll write here now. Now we'll write here y maximum equal to minus WL cube by EI will become here 3EI. 3I. So this is called maximum deflection. What is called? WL cube by 3EI. This is called maximum deflection. We got the maximum deflection. So now you are seeing negative sign. What is negative sign represent? Because deflection is below the beam or deflections will be in the downward. So this way we can calculate the slope and deflections. Slope we got WL square by 2EI and deflections will get WL cube by 3EI. Okay, so that way we can derive. Okay, students, watch this video and subscribe the channels. Okay, thank you.